Okay, we're in section 26 now. And it's really always the same type of discussion we have about this. Section 26 really kind of divided into three parts. There'll be contents, there'll be examples, and there'll be exercises. My intent here is just to briefly go over what your responsibilities are, and your responsibilities are to follow. That you need to read the contents, you would need to understand the examples, and after that, get busy with doing the exercises. Now, the document is only available to the Prison Mathematic Project participants. All right, now I realize some people want to get access to this. My name is Ron Bannon. This document will be published sometime in the future. You can certainly reach out to me if you have questions or concerns. And that's my email address. And that's supposed to look like bannon.us. All right, now that's exactly what it is. B as in boy, the @ symbol, NNON.us. Now, by the way, when you get to these things, it's sort of like a mystery what it's going to be, and you just got to scroll forward, and they really want you to read about it, all right? Now, they're talking about, LCMs and HCFs. For the most part, that was the language they used back then, and that's important. So I'm going to claim over here. Again, a lot of people would read through that and say, oh, gee, I really understand what's going on over here, but it's really the same story over and over again, all right? So what I'm going to do, get to the work, all right? But again, I would recommend strongly that you read that stuff. So here comes the problem. They want you to get the LCM between these two expressions, all right? So the expression, this is the first expression, and that's the second expression. Now, my gut feeling about this is that if they're giving me something, the worst case scenario for an LCM would be the product of those two expressions. I would hate to think it's going to be that. So what I want to, go about is just simply see if I can factor it. And I'm looking at it, and I can really factor the first guy by inspection. You get x and x. Not always by inspection, but I'm saying it by inspection's easy. 7y, 1y, and then I would say minus minus. Now, there's a really, really, really good chance that second expression is going to factor, and it'll have something in common with the first expression. Something in common. Well, someone said, how are you going to do that? And I got to be honest with you, for a lot of students, that's horribly difficult. They're looking at, they don't know even where to start with that. There are many ways to do it, by the way. But what I'm looking at, I'm kind of looking at, and I'm hoping that it's got a factor. And out of these two factors, x minus 7y, x minus y, I'm going to say x minus y is a really easy factor. And I'm going to say it seems reasonable to me that that would be a factor, and I'll tell you why. Because if x minus y is a factor, that means a root of it would be x equals y. All right? So someone says, well, could you plug it in and verify that? Well, I'm going to do that now, and then I'll do my long division. What would you get? X cubed minus 9x cubed plus 23x cubed. You may know what I'm doing. I'm just replacing the y with an x, minus 15x cubed. Now, what do you get over here? Well, add it together. 1 minus 9 is minus 8. Minus 8 minus 15 is minus 23. And 23 plus 23 is 0. So now I really do know it's a factor. So not just wishful thinking, by the way. It's good thinking. So what I'm going to do is I'm going to use that to find the other factor. I'm going to go through the long division for you. So I'm going to do x minus y. And I'm going to divide that into that polynomial. And I know it's going to go in with a nice remainder of 0. And I'll write this down for you. And I kind of liked long division. When I first did long division in grade school, I really found it quite difficult. And I did make mistakes. There's no doubt about it. So let's take a look. What times x gives you x cubed? X squared. Now, someone says you don't have any place to put it. I'll just put it on top. What do you get over here? X cubed. And then what do you get? You get minus x squared y. I'm going to subtract. And what do you get? You get minus 8x squared y. I'm going to jot the places down now. 23 xy squared minus 15 y cubed. We're going to repeat. Well, what times x would give you minus 8x squared y? That would be minus 8xy. Let's see what happens. What do you get? Minus 8x squared y plus 8xy squared. I'm going to subtract now. What do you get? 15xy squared minus 15y cubed. Let's repeat. What are you going to get over here? Plus 15. 15 times x is, oh no, I'm sorry, I misspoke. I need a y squared. Sorry about that. So I give you 15xy squared minus 15y cubed. Well, as promised, I get a 0. So right now I'm going to say this over here. This thing factors to x minus y times x squared minus 8xy plus 15y squared. Now again, looking at the other guy is a quadratic. I've just taken a cubic and now I've got a quadratic. Quadratics are much easier to deal with. So let's see if we can factor that. You're going to get x minus y. And then, just by inspection, I get x and x. I want to just put a line over here, say it's not part of that. And then 15, I'm going to say 3 and 5. So minus 3y minus 5y. Now, what's the LCM? The LCM must contain those factors. What factors do I see? X minus 7y, x minus y, x minus 3y, and x minus 5y. All right, now let's go through this again. It's the maximum number of times those factors occur in any one factorization. So x minus 7y occurs at most once in any one of those factorization. X minus y occurs at most once in any one of those factorization. X minus 3y occurs at most once in any one of those factorizations. By the way, the factorizations are these. And then, last but not least, the x minus 5y occurs at most in any one of those factorizations. So, I'm going to write down the LCM. Oh, it's over here. I'm sorry, I didn't do that again. Did I get it? Let me get my eraser out. Didn't need to do that. Well, let's see. I got this factor, I've got this factor, and I've got that factor. We're doing okay. And that's it. All right? So what happens now? They get exercises. So Wells is of the opinion, after showing you, this, maybe a little more difficult factorizations, but it's really a continuation of what we've done in the past. No different. All right? Now, again, you may read Wells's work and get a different take on it, but the bottom line, the take here is LCM, LCM, LCM. Just to remind you, when you're doing these problems over here, if you're going to factor, I strongly recommend you start with the easy guy, and squares are easier than cubes. Once you get the square, take a stab at the cube. It has something to do with the square most likely, all right? So each one, well, a little more difficult. Which one do you do over here? Well, they both look equally difficult. Start with one. Try to figure it out. Again, we give you answers. Yes, these problems are more difficult. Also, they give you 3 terms over here. I want to point out, I should say 3 algebraic expressions. They're multi-termed. The bottom line, it's same deal. You got a factor, factor, factor. I think you probably know the theme of algebra, a lot of factorizations. Again, factor, factor, factor. It's work, though. I know that. There's not many questions over there. Again, I do go through the SAGE. Maybe you're sick and tired of hearing that. It's a computer algebra system. Go to the website. You can either download it or use the interactive web-based, and we give you some code to type in. All right, why do you type the code in? You're trying to learn. You really are. One is just simply trying to faithfully type what someone gives you, but more importantly, hopefully you're trying to make sense out of what's given to you. And code really needs to be read. It does. And so not read to you, but read. Okay, so I'm going to say again, if you need to reach out to me for whatever reason, again, my name is Ron Bannon. Whoops, sorry about that. And my email address is Bannon, and that looks like this. B as in boy, ANNON.US. And again, if you need to reach out to me, like if you think there's an error that needs to be corrected, or you need some additional support with the material, please feel free to reach out. Now, I can't, give everyone dedicated time, but who knows? It can't hurt to ask, right? All right, thank you for paying attention.